Welcome to part 5 of building a vertical head mount for the K&T mill. Here I'm just showing what happens when you engage the X feed when you're trying to drill a hole in the Y direction on accident. It is hard on the drill. The X feed has a locking feature to lock it out so you don't inadvertently engage it. So now I'm using that. Here I'm drilling the holes for the side mounts that will be welded onto the base plate that we finished up in the previous video. Just clamping the two side plates together and drilling all the holes, putting a little chamfer on the holes. But these are the holes that will mount the round part that allows the head to swivel. And here you can see, just test fitting it up. The T-nuts are in the T-slots that are cut in the ends of the round, and then a center pivot for the center bolt. You get to see the rotation, and then we'll flip it over and make sure the other side's going to work as well. In order to mount the parts on the rotary table to round off the edges, I needed to make a plug that would fit in the center hole of the rotary table and then up in through the center hole of the side pieces. I just drilled this using the Jacobs rubber flex collet holder. Here we're going to see if we can mount those parts up on the rotary table. It was a little bit too snug, so using the key thinner trick of the sandpaper on a split rod, got that extra little bit out to get the part to fit on. Here are the two side pieces roughed out on the bandsaw. Very rough, as you can see. This hot rolled still wasn't very happy on the bandsaw. Here I'm using my thread detective. If you don't have some of these, you should get them. They're super handy. I've seen them on the Enco catalog. I got mine, I think, off of an eBay site, but got a female and a male thread for all the metric and standard. There's a metric and a standard SAE. Because my rotary table is just a horizontal, no vertical, and mounting it up on an angle plate to turn it up so I can use the spindle on the horizontal spindle to machine these side supports. I had to square the rotary table up with the column on the mill, just using some 1-2-3 blocks. Get it plenty close enough for what we're doing here. And then just adding a clamp for good measure. Try and make sure to hold it. So here we're just running an end mill along the edge to round over the side mount to match the radius of the round that'll go in it. I just marked the angles, the degrees on the edge of the rotary table to make sure I tried to rotate through the same angle for both of the side plates. The roundover was done in about 3 passes, a third of the width, which is a 1-inch piece of 1-inch plate. and so 3 passes around each of those seem to take care of it. I'm starting with a second pass. I initially thought I'd have to do several depths moving the table in the X direction, but I was able to kind of hog it all off in one setup. Finished result, in serious need of some deburring. I'll go ahead and get this one pulled off the rotary table and get the other side mounted up. So here's both sides rounded over and mounted up onto the round cylinder with a real nice fit. Unfortunately, I should have gotten a little more clearance there, as you'll see in a bit, for the other part that's going to mount onto the cylinder. But as you can tell, I'm pretty happy with how it's turned out at this point. Kind of exciting to see the work to this point coming together. And that part will get welded on there to hold the vertical head. Unfortunately, by getting such a close fit on the side mounts, it's going to cause me some problems a little bit later. Here we're just cleaning up the side mount pieces to mill off the excess from where the bandsaw kind of roughed out on the bandsaw. With the side pieces done, it's time to move on to the cylinder. Here I thought a great idea to try and mount them using the bolts and the center bolts. Turns out that was a really bad idea. As you'll see right here, as soon as the cutter comes into it, the part rotates, and so we've got a slow motion replay to watch that part rotate. That was a really bad way to clamp that. So now I've got the apprentice marks along the edge of the part. Got to decide what I'm going to do with it. I'm putting it back in the lathe to clean up the marks, but decided I would go ahead and leave them to remind me to be more careful in the future. Again, with a different clamping method. I'm using the T-slot on the table to align the part. It's pretty much dead on, true to the travel in the X direction. Just setting the part down in that, and hopefully this time clamping it a little more securely. Now I'll try that again, milling the flat. This is just to aid in the positioning the other part on it for welding. Now with that part milled, to bring you in to show you the marks from my screw up there. They are. Decided just to leave them. I could look at them and remember. Got to pay more attention. But Facebook does a nice job though. So after milling the flat on the cylinder, I realized that the head mount would now also foul the side pieces, because they were cut to the same, essentially the same radius as the diameter of that cylinder. So now I have to take the head mount down the same amount, actually a little more than the flat that I milled onto the round. Just pretty much just poor planning on my part to take into account what I was doing. Need to do a better plan of operations, think through things. But there's always a workaround. Well, there's usually a workaround, so we're working around it. These last couple operations are a good example of how handy a horizontal mill is. It's a really secure, rigid setup for milling parts like this, as compared to the using a vertical head. I'm going to start getting the parts ready for welding. I thought that since my note paper was 3/1000 thick, that I could stack two pieces together and get 6/1000 clearance on each side between the center cylinder and the side mounts. And I probably did until I started welding and things started warping. So other extraordinary measures were required to get things to work out. And once it was welded up, after getting both sides mounted up, I trimmed off the excess paper and started trying to figure out how I was going to get it to lined up right on the base plate. Since the base of the back plate is what I've been using to mount the base plate by holding it on the table on top of an angle plate, I thought that would be a good datum for aligning the cylinder parallel to that base plate. So I just took a dial indicator or test indicator and ran it along there until I could get it that cylinder parallel with the base of the back plate. Turns out this piece of stock that I picked up at the freight damage deal that said 01 tool steel. As I was looking through the scrap pile and noticed it had said Storrick and had a Storrick number on it. Turns out it's a nice straight edge that they were selling for 50 cents a pound. Now I'm going ahead to get to parts ready for welding. I masked off the areas I was going to weld, and then used liberal amounts of the anti-spatter spray to try and keep any spatter off the areas that I didn't want other than the weld, basically. I got this spray from Eastwood and ordered some stuff from them, saw it in there and thought I'd give it a try. I was pretty impressed. It worked really well, kept the spatter off. I since got some other stuff that's industrial strength. It works better, but the fumes about kill you, so you gotta use it with good ventilation. This Eastwood stuff the fumes aren't too bad from that. After getting the anti-spatter on, I went ahead and pulled the masking tape off and tacked it up, and then went ahead and welded over the whole part with some welds. Not necessarily good welds, but welds, using some 6013 because it's what I had. Now with the anti-spatter spray baked on, it takes a little bit of scrubbing and wire brushing to get off, but as you can see, there's very little spatter and crap from the welding on parts that don't need it. But as I said, it does take a little bit of scrubbing to get that off once it's been cooked. Now the big question remains, will the cylinder fit? And probably to nobody's surprise, the answer is no, it's not going to fit without some work. A little love from grinder and some sanding discs. We've got it prettied up a little bit and ready to get serious about testing the fit of the cylinder. And like I said earlier, it doesn't fit. So now the head scratching starts. You might have noticed my limited supply of measuring tools don't include anything bigger than about 6 inches. So creative use of 1, 2, 3 blocks and other devices is being used to try and help figure out how much bigger these things have to go to get that thing in there. So now it's time for some serious head scratching. I'm going to have to do that off camera for a while, I think. So, given my precision measurements, turns out I need to find about 16 thousandths in there to make this work. So, I'm going to try and use the Harbor Freight Porta-Power hydraulics to push that open a little bit more. Actually, it's pushed open about as far as that little ram's going to get it, and then it's still not going to get it in there. So, time for yet another plan. I don't know what plan we're on, but we're pretty far down the alphabet by now. The plan that worked involved a piece of threaded rod all thread running through to help the hydraulic jack. We're able to get it in and keep it open enough to allow the cylinder to rotate. The hard part was getting it open wide enough that the spring back wouldn't pinch the cylinder in so tight as to not allow it to move. With the combination of the hydraulics and the threaded rod, we're able to get it open wide enough that the spring back didn't pinch on that too much. But after a lot of work on this, I kept getting too much spring back to allow that cylinder to stay free in there. So I thought maybe peening, like you would use to relax something, might help relax those welds a little bit and allow that cylinder to be in there, but be able to rotate like it needed to. I don't know if it was the peening or just got tired of fighting me and gave up, but whatever it was, turns out it worked. With a liberal dose of editing, things finally fell into place, and we've got the cylinder in where it needs to be. So this is probably wrap up part 5 of this, and part 6 will follow and should get us all the way done. We just need to mount the disc. The head will mount to and get it painted and mounted up on the mill. Thanks for watching, and hope you enjoyed.